Alright, the last section of chapter 4 is going to be section 4.5, and this is the product sum and sum product identities. So let's start with the product sum. These are the product sum identities. Well, the first one is sine x cosine y equals 1/2 of sine of x plus y plus sine of x minus y. Now, as you can see by looking at this, what this is this is just an application of our difference and sum and difference identities, okay? Basically what they're doing here is if I were to take the sine of if I were to take the sine of x plus y and the sine of x minus y, which that's going to be sine x cosine y plus cosine x sine y. And if I were to, and we have sine x cosine y minus cosine x sine y. So if I were to add this together, I would have the sine of x plus y plus the sine of x minus y equals, well, these cancel each other out, so I'm just left with 2 sine x cosine y because they're like terms. And if you divide by 2 here, you get the identity. So you see, that is how we derived that identity. Okay? You need to know that identity. Alright, and there are 4 of them that are exactly like that. And so here, what you need to do while we work this out, you need to be on page 268 in your book. So pause it, get out your book, page 268. You're going to need to follow through with this with me in your book in order to be able to understand it. Okay, so, alright, so where we are, let's work an example. Page 268, you see the pink box. That's the 4 identities, okay, that I will give you on test, of course. But here's the problem. Write the product cosine 3t sine t as a sum or difference. Alright, so if you're looking on page 268 in that pink box, what you need to do is, notice we have cosine 3t, sine 3t. So which one has cosine t, sine t? Well, that's going to be the second one. That's going to be this one right here in the box. Cosine x sine y equals 1/2 of sine of x plus y minus sine of x minus y. So this is the particular identity we're going to use for this problem. So the only difference is where we have x and y, we're going to have 3t and t. So this is 1/2 of the sine. Alright, so x in this case is 3t. Y in this case is t. So I'm going to put 3t and t in, just like so. And so this is 1/2 the sine of 4t minus the sine of 2t. And if you do your distributive property correctly, you've got 1/2 sine of 4t minus 1/2 sine of 2t. And you got your simplified answer, just like that. Okay, but you got to look carefully at what you have and match it up to the correct beginning, because I want you to look at that pink box on page 268. Those things are very, 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 I can't say put enough varies in there, similar. Okay, so you've got to make sure and match it up to the correct one. Now let's see an actual applied problem with this. So we want to evaluate the sine of 105 degrees sine 50 times the sine of 15 degrees. Excuse me. Sine of 105 degrees times the sine of 15 degrees. Well, notice sine and sine, that's the third one in the pink box. That's this identity right here. 1/2 cosine x minus y minus cosine x plus y. All right, so take your 105 and your 15 and plug it in. So it's going to be the cosine of 105 minus 15, okay, minus the cosine of 105 plus 15, which is going to be 1/2 cosine of 90 and cosine of 120. Now these are all angles we can find on the unit circle, so that's nice. So we have 1/2. All right, the cosine of 90 is 0. And the cosine of 120 is negative 1/2. So really what we have here is 1/2 times 1/2. Because that inside the bracket simplifies to 1/2, which is going to be 1/4. So the sine of 105 times the sine of 15 equals 1/4. Now, these were all starting with a product. All those on page 268 start with a product, and we divide it out into a sum or difference. Now, what happens when we go the other way? Well, that's a different set, okay? That's a different set of identities. And these identities are like so, and the proof is on page 269 if you want to look at it, but it's very understandable in what they're doing here. So basically it says this: the sine of x plus the sine of y equals 2 times the sine of x plus y over 2 cosine of x minus y over 2. Okay, and there's sine x minus sine y, and it is 2 cosine of x plus y over 2, and sine of x minus y over 2. Now, if you notice in the proof, what they did is they started with a product sum problem, and then they assigned variables and to make the problem a little easier, and then solved a system of equations by substituting to get their answers. But the proof is not the proof is, you need to know the proof, but you need to know even more how to use these things. So and you'll be provided with the identities, but definitely look at the proof. And if we have time, I'll do the proof for you. But you also have cosine of x plus cosine of y, which is 2 cosine x plus y over 2, cosine x minus y over 2. And then you also have the cosine of x minus the cosine of y, which equals negative 2. So be careful. This is the one that's a little different. Negative 2 times the sine of x plus y over 2 times the sine of x minus y over 2. Okay? So these are our 4 sum to product. We're starting out with a sum now, notice, and we're going to a product. Okay, so let's look at an example. Let's do this. Write the difference. Sine 7 theta minus sine 3 theta as a product. As a product. Okay, so obviously that's sine x minus sine y, so that's the second one. So sine of x minus sine of y, and I would practice writing these out. It's 2 cosine of x plus y over 2 sine x minus y over 2. Now, I know I'm giving you these identities, but practice writing them, folks, because if you have to sit there and search forever and a day on the final for all of these different identities, it's going to hurt you. So you need to have some idea at least of what it looks like, so you can search for it a little more quickly. Okay, so x is 7 theta, y is 3 theta. So to solve our problem, we've got 7 theta plus 3 theta over 2 sine of 7 theta minus 3 theta over 2. So when you simplify this, you get 2 times the cosine of 5 theta, the sine of 2 theta. So that's taking a difference and writing it as a product. Now, it would, if it was a sum, we would just use a different formula, but we would do it in much the same fashion. Okay, so let's look at an actual applied problem of this now. So, for instance, let's find the exact value of the sine of 105 degrees minus the sine of 15 degrees. This is similar to the one we had before. Now notice, before we started out with a product, so we had to find the right product formula. Now we're starting out with a difference. So, and we want to solve this using the appropriate sum product identity. Well, the sine of x minus the sine of y equals 2 times the cosine of x plus y over 2 sine of x minus y over 2. Alright, so we can take our 105, which is our x, 15 being our y, and we can plug them straight in. Now notice what we're left with here. This is the cosine of 60 after you divide it out. This is the sine of 45 degrees after you factor it out. Now we know what those are. Okay? So this is 2 times the cosine of 60 is 1/2. And the sine of 45 is the square root of 2. over 2. So our answer is the square root of 2 over 2. Alright, so be able to solve a problem like that, you just got to be able to navigate between them, because it might not say using the sum or difference, sum to product property. You just got to realize that it's starting out with a sum or difference, so you've got to go to the product. If it starts out with a product, you got to go to the sum or difference. Okay, so keep that in mind. Now that's all, believe it or not. That's all of section 4.5. So if you have questions, please don't hesitate to let me know.